Alright, Kipsters, welcome back. Today's lesson is going to be over transformations. So what happens if I added or changed the scaling of the original parent function of a linear graph? We're going to see what changes the steepness, what changes the y-intercept. So first, I want to talk about a parent function. The parent function is the very first linear equation ever made, which is just x. As you can tell, it is in red in this graph. I even have the equation over here on the left-hand side. So I want to know what happens if I decided to add 4 to the original equation. As you can tell, my new equation is in purple. The very first thing I notice, or the y-intercept is no longer at 0, 0, but at 0, 4. So when I added 4, it changed the y-intercept. Did it change anything else? So let's check the slope of my parent function. And I see my slope is rise 1, run 1. Well, 1 divided by 1 is 1. So I know the parent function has the slope of 1. And let's check my purple graph. I rise up 1, run across 1. The slope are the same. So that means the only thing that did change was that y-intercept. What happens if it's not plus 4, but minus 3? Once again, I notice that it changed y-intercept is now going to be at 0, negative 3 instead of at 0, 0. And the slope did not change. So I know the constant is going to change my y-intercept. What happens if we change the slope? Right now our slope is at 1. What happens if we into a half? And remember, the original slope is at 1. I notice that the steepness of the purple one lessened. So it's now less steep compared to the parent function. So if half makes it less steep, so let's change the steepness. Instead of having a fraction as my slope that is less than 1, what happens if I decide to grab not a fraction, but a whole number that is greater than 1? Let's go with a 5 in front of our slope. Well, right away I notice that the steepness increased compared to my parent function. My parent function is in red, and then my new slope, which is 5, increase in steepness.